DUG is coming by November. That sounds like a massive leap, doesn't it?
It sounds like the kind of leap that changes the entire competitive landscape. We're moving from building models to building armies.
Welcome back, I'm Bella.
And I'm Michael. This show's scripted and produced with AI, built by Terafab, pulling today's stories straight from blog.terafab.com.
If you want these landing in your feed most days, go ahead and subscribe. Let's get into it. So the news is that OpenAI is cooking up another giant model, codenamed DUG, and it's slated for November. That sounds like a massive leap for the company.
It certainly does. The implication is that this isn't just an incremental update. The summary suggests it could completely overshadow competitors like Anthropic's Fable.
That scale is what really gets me. It sounds like the focus is shifting from simply building the next thing to pushing the absolute boundaries of what AI can achieve.
Precisely. The narrative is moving from the engineering challenge of, can we build it, to the far more complicated operational challenge of, how do we deploy it responsibly?
I wonder where that places us in the ecosystem. Do you think this race for sheer scale will define the next major inflection point in AI development? Wow, $16.8 billion for a chip plant in Texas. That is an absolutely staggering commitment. It sounds like they aren't just building a factory, they're trying to control the entire silicon supply chain.
Indeed, it's a massive pivot away from traditional foundries. The real shift here isn't just the physical plant, but the vertical integration Tesla and SpaceX are aiming for, feeding everything from Optimus chips to orbital processors.
That makes sense when you think about the geopolitical context. It really highlights how critical domestic manufacturing is becoming for AI and space infrastructure right now.
Exactly. When you look at these supply chain tensions, building that kind of integrated hub becomes less about cost and more about national strategic advantage. It's a very heavy move.
So the core question seems to be how fast other competitors can adapt to a world where the largest chip plants are built by vertical integrators, instead of just outsourced foundries.
Precisely. The race is now about strategic integration rather than just incremental improvements. It puts the pressure on everyone else to figure out their own silicon futures quickly.
This is fascinating. So, Hwatsing Technology integrated real-time measurement directly into the polishing tools to improve wafer surface uniformity.
Exactly. It's not just a small tweak. Integrating that metrology system into the CMP process directly addresses the fundamental need for precision in semiconductor manufacturing.
That makes sense when you think about material waste. If they can measure and adjust in real time, it sounds like a huge win for reducing waste in these complex processes.
It really highlights how foundational process improvements, rather than just advanced lithography, are quietly driving efficiency and cost reduction in the mature semiconductor sector.
It puts the focus back on data-driven optimization. I wonder how much of this kind of real-time feedback is being adopted by other manufacturers globally right now. I just read about imec's review on in-fab metrology, and it sounds like a massive look back at 4 decades of semiconductor manufacturing.
It is. The real takeaway is how quickly we've moved from predictable scaling to grappling with the complexities of 3D system stacks. The physical limits are starting to really bite.
And that brings in the AI element. They are suggesting that specialized hardware sensors combined with AI inspection algorithms are the future for ensuring yield.
Exactly. It's less about just keeping up with Moore's law and more about making sure every single defect is caught in this increasingly complex environment.
So, for executives and engineers, the big question really is, how do you prepare for this metrology revolution that is already underway? Jane Street just dropped a puzzle asking people to reverse engineer an ASIC from its raw chip layout using open source tools. That sounds like a massive challenge for hardware engineers.
It definitely sounds like a trip into the deep end of semiconductor design. It really puts into perspective how much proprietary information is locked inside those physical layouts.
The fact that they are using open source tools makes it even more fascinating. It really highlights the push for transparency in such a complex supply chain.
Exactly. It forces the conversation about security and design transparency. I wonder how far that process can actually take us in unlocking the mysteries of modern chips.
Hadrian just closed a massive Series D round, raising $1.37 billion for their AI defense manufacturing business. That puts them at a valuation of nearly $7.9 billion.
It's a fascinating pivot from traditional defense contracting to full-scale AI automation, especially focusing on precision parts for things like drones and submarines. It shows how intensely supply chain resilience is driving tech investment right now.
Exactly. They are fundamentally changing the manufacturing approach by moving away from manual labor to intelligent, scalable factories. It's a huge shift in how national security industries operate.
The real kicker is the implication for geopolitical tension. If you can automate the production of critical munitions parts, you gain a massive layer of operational resilience regardless of external volatility.
So it's not just about efficiency. It's about creating resilient, self-sufficient production chains in high-stakes environments. That's a paradigm shift we should be watching closely. So we're looking at a major shift in the AI chip landscape, where Chinese makers are planning to dramatically increase their spending on domestically made accelerators. That's a significant move.
It is. Doubling spending from 30 to 46% in 1 year signals that this isn't just a market trend, but a deliberate strategic pivot towards self-reliance in critical technology.
It makes sense when you consider the geopolitical tensions and export controls reshaping the global supply chains. It feels like a direct response to external pressures.
Precisely. When external factors dictate supply, localization becomes the primary defense mechanism. It's less about pure efficiency and more about national security in the tech space.
And for us, the multinational companies, this really puts the pressure on figuring out how to balance global collaboration with the need to localize these essential supply chains.
It forces a serious reassessment of where those critical AI workloads are being managed, pushing everyone to diversify their ecosystems away from single points of failure.
This story about the former SK Hynix employee really hits home. It shows that protecting intellectual property in the semiconductor world isn't just about firewalls, it's about people.
Precisely. It highlights how geopolitical tensions translate directly into tangible risks for critical technology. The focus shifts from physical infrastructure to human capital when we discuss trade secrets.
It makes you wonder how companies can manage that balance. How do they attract the global talent they need while simultaneously ensuring that sensitive data remains secure?
It requires much stricter internal safeguards and better training, frankly. The incident underscores that security in this sector is fundamentally about managing access and trust, not just perimeter defense.
So ultimately, it feels like the industry needs a new kind of international collaboration to enforce these standards. It's a huge reminder that security is deeply intertwined with innovation. And that brings us to our quick hits for the close of the episode.
Let's dive in.
Meta released Muse Glimmer, a 30 billion open-weight model designed for local AI agents running on consumer hardware.
Nokia and NVIDIA's $1 billion partnership aims to embed GPU-grade AI hardware directly into 6G radio access network equipment.
SK Hynix just greenlit a $38 billion investment to build 2 massive memory fabrication facilities to address AI infrastructure bottlenecks.
Data Direct Networks is experiencing a renaissance thanks to the generative AI boom.
Lightspeed led a $37 million Series A in Andorra, an AI-native platform automating internal audit processes.
A coordinated wave of AI-enabled voice phishing attacks has targeted major hedge funds.
Enrich Labs unveiled Helena, an AI marketing agent that autonomously improves and iterates campaigns across ads, SEO, and social media.
ByteDance entered pre-training for China's largest AI model.
South Korea's AI-driven memory chip boom is translating into record bonuses for factory workers.
GitHub has just made Copilot smarter and safer with the addition of side chats and isolated work trees. That's today's show, scripted and produced with AI by Tahababa.
You can read the full write-up anytime at blog.tehababa.com. And if you want these landing in your feed most days, hit subscribe.
See you next time.